Really, I don't trust these bitches like that.
Welcome back to another video on a new series on Postgres. In part 1, we've learned how to run Postgres in a container. We learned about the basic networking, how to get the container up and running, as well as persisting data. And that was pretty straightforward. In this video, we're dialing it up a notch and we're learning how to configure Postgres, as we're laying the foundation for more advanced replication and streaming concepts. Now we've got quite a bit to get through, so without further ado, let's go.
Really, I don't fuck with them. These bitches like that. Hell nah. Trust these bitches. Really.
So if you take a look at my GitHub repo, I have a storage databases folder, and in here I have all my database tutorials such as Postgres. In the Postgres folder we have the part 1 introduction folder with a readme, and this is our introduction to Postgres, which is part 1. That video is linked down below. In this video we're going to be taking a look at part 2, which is the configuration, and there's a readme as well. And in this video we're going to take a look at how to configure Postgres. We're going to run a simple Postgres database, look at all the configuration options, and everything is listed in this readme file. So be sure to check out the link down below to the source code so you can follow along. So let's kick off things where we left off in part 1. So we're going to run a simple Postgres container and learn about configuration. So the first thing I'm going to do is change directory to my storage databases Postgres, and the second folder I'm going to change directory to that, and then I'm going to run my simple Postgres database. So I say docker run -it. I'm going to call my database Postgres. I'm going to change the Postgres password. I'm just going to pick admin123. This is the admin Postgres password that we'll be configuring, and then I will mount a volume. In part 1 we've taken a look at persistence and how to mount our data to the host so we don't lose our data when the container restarts. And then also I'm going to be exposing port 5000 and use that to connect to. In part 1 we demonstrated some networking concepts with containers, and then what I'm going to do is I'm just going to map that to port 5432. That is the default port for Postgres. Now default values can change, so I generally don't encourage to rely on defaults, and I like to explicitly configure my application using configuration files. And then I say I want to run Postgres, and I want to run Postgres 15. So I go ahead and take this docker run command, I paste it to the terminal, and I start up my Postgres container. Now throughout the series we'll be taking a look at configuration files, and mainly try to use configuration files where possible so that we can keep everything in files, which means everything is in Git and becomes our source of truth. And we'll purely use environment variables for small toggles or something like passwords, where we can use something like a Kubernetes secret to inject it, just so that we don't store passwords in Git. And it's much easier to maintain environment variables outside of Git. Now if we go to Docker Hub for the Postgres image and we scroll down, they actually have documented all the environment variables that the Docker image supports, and you can see there's quite a few of them. Now I've documented some of the important ones that we're going to be using in this demo. So for example, I've got a small table here, the Postgres user. This is the username for the Postgres admin, the Postgres password. So the password we already set in our docker run command, the Postgres database. This is the default database for your Postgres server, and PG data, which is the path where data is stored. This is pretty much the same path that we mounted in when we run our Docker container, which is var lib postgresql/data. We've taken a look at persistence in the first video. This is just the configuration option, so you can tell Postgres to store the data somewhere else. And that's why it's good not to rely on defaults, because if Postgres decides to change this in the future and you have not set it or configured it, your data will be expected somewhere else. So always good not to rely on defaults. But firstly, let's take a look at configuration files. Now when dealing with Postgres, there are 3 main configuration files that we should know about. There is a user mappings file configuration called pg_ident.conf. This allows us to map operating system user accounts to database users. So if we wanted users to use their Linux username and passwords, or their operating system account that they use to sign into their machine, and use that to connect to Postgres, then you have the host-based authentication file. This is the pg_hba.conf. And this file is very important because it's kind of like the Postgres firewall configuration. It's important because it tells us which IP addresses or which users we can trust, and it controls how users and clients will log into Postgres. And then last but not least, we have the Postgres.conf configuration file. This is the main Postgres configuration where all the magic happens. And this is where you control everything there is about the Postgres server. And the moment you see this configuration file, you will realize just the customization depth and advanced depth that Postgres has. So we'll start with the authentication file, the PGHBA file. Now, before we go through these files, there's one important thing that I have to mention. In all my guides, even in my Redis and my Kafka series, as well as this database series, what I do is follow the very similar practice when I learn configuration. I generally try to run the technology in Docker first, and then I go inside the container and find all the configuration files and copy them out. This gives me an idea of what the default configuration files look like. Then I spend some time learning and going through the documentation to understand the configuration files. And then finally, I look at how to explicitly set these configuration files so that I don't rely on the default ones. So before we continue, just a quick word from our sponsor who made this video possible. So you have Kubernetes clusters. How many pods and deployments do you manage? Across how many Kubernetes clusters? How many environments do you maintain? With Kubernetes in the cloud, it is very easy to reach scale. And with Kubernetes at scale, the chances of misconfigurations are high. Datree is an open source tool that can help us secure our Kubernetes environments by blocking deployments of misconfigured resources. Datree is very easy to install on your platform. Once Datree is installed, when deploying resources to Kubernetes, Datree will create warnings when misconfigured resources are deployed to your clusters. And when ready, you can enforce your policies by turning on Enforce mode. Now, when deploying resources to Kubernetes, Datree will block when misconfigured resources are deployed to your clusters. Datree has a dashboard that shows your cluster's score and all failing policies, but more importantly, shows you a detailed view of each failure, the fix complexity, and exactly how to fix it. Datree also has an open source CLI, so your engineers can test and validate their deployments during development. Datree ultimately helps you build a roadmap to better Kubernetes security and best practices, so your cluster can go from a D score to an A score and prevents your cluster posture from degrading. This video is proudly sponsored by Datree. Remember to check out the link down below for the full Datree tutorial. So to learn about the configuration and where it's stored, what I've done is just consult the Postgres documentation, did a bit of research, and I found something interesting. When I run Postgres in my Docker run command, notice that I mount my working directory into PG data to persist my data. Postgres writes all its data into varlib PostgreSQL/data, but it also writes the default configuration there because I have not specified any configuration as part of this Docker run command. So if I take a look at my volume mount on the left side, I have the PG data folder right here, and notice that there is a PostgreSQL configuration file here. This is the default configuration file. There's also a HBA configuration and an ident configuration. The three config files that I mentioned are right here. So you can open these up and take a look. So if we take a look at the hba.conf, we can see that it is a fairly sized configuration, but the defaults are all set here. If we take a look at the ident.conf, it is pretty much empty. It's just commented out with an explanation on how it works. This is the user mappings file. We'll take a look at this in a second. And then we have the PostgreSql Conf file. This is a massive configuration file. They talk about the file locations for specifying configuration files, connections and authentication, SSL settings, and if you scroll, this file is large. You can spend a couple of days just going through and learning all the configuration options for Postgres. So what I've done is I've copied those default configuration files out into a config folder. So I have them all three over here, and then I've documented them in my README. So we'll take a look at the basic settings. Now we'll start with the HBA configuration file. Now this configuration file controls who can access our Postgres server and how it's accessed. I would encourage you to run the container and take a look at the default configuration files because they explain using comments what each of the field means. Now in my config config folder, I've got a basic one already set up and configured. And you can see I have this configuration populated. You specify a type, a database, a user, an address, and a method of authentication. If we take a look at the default configuration, it explains pretty well what each type and field means. So you can see the types specified here. There's local, there's host SSL, host no SSL, host GSS ENC, and host no GSS ENC. So these are all the types of connections. Now the database can be all databases, same user, same role, replication. So if we set up access for replication only, it can be a database name if you want to give specific access to a specific database, or a comma separated list of databases. We'll take a look at setting up replication in a following video. Then the user field is pretty self-explanatory. It can be set to all or the username we want to allow access to. And then you have the address column. So this specifies the set of hosts the record matches. It can be a host name, or it can be IP address, or an IP address range. So we can allow access from all IPs within, let's say, a Kubernetes cluster, or we can provide a specific range of IPs. Or if we make our Postgres server public, we can put IP whitelisting in here as well. And then there's the method that we can specify. We can say trust, reject, MD5, password, and various other different types of methods for authentication. Also, password sends the password in clear text. If we use MD5 or SHA-256, they are preferred because they are sent in encrypted passwords. So here you can see is the default settings that's provided by that configuration. So in part 1, we noticed when we connected inside of the container, we did not get prompted for a password. This is because all local connections are trusted. So if you want to turn that off, you need to remove this line to disallow people connecting from local. So if you're within the container, it will allow you to connect without providing a password. You can change this method trust to password or MD5 or SHA-256 to enforce a password to be sent. So you can use this file to lock down the access to your Postgres instance. In a future video, we'll take a look at setting up replication and how to set up a specific user that can replicate. So we'll lock this down quite a bit. The next configuration we'll take a look at is the pgident.conf. This is a mapping file where we can map Linux users or system users with database users. Now we can take a look at the official documentation to figure out how this file works, and this is the user name maps file. It's basically just 3 columns, the name of the map, and this is just an arbitrary name that will be used to refer to this mapping in the previous configuration file we've looked at. The second field is a system username, so this is the username for, let's say, the Linux user in this case, and the database username that we want to map to. So you can see some examples of how this is set up, where they create a new map called mymap, and then they put some regex to map to specific users that might sign into Postgres, and then they can map them to database users like the guest user. Now similarly, if you take a look at the default one that is in the PG data folder, you can see the ident configuration is there as well, and it is actually blank. There is no mapping set by default, but it does give an explanation here of how this file works as well. Now this is not a feature that we'll be using in the series, so we'll skip this file for the time being. Now the next configuration file we'll look at is the big one. It's the Postgresql.conf file. This is the main configuration file for PostgreSQL, and I would highly recommend to take a look at the default configuration file that you can copy out of the data volume, as it describes with comments exactly how this configuration file works. But as you can see, it has massive depth. It is almost 1,000 lines in length. Now in this video, I'm going to take a look at the most important settings that we need to set. If we scroll down, the first one is file location. This is very important because I would prefer, when you configure Postgres, to tell Postgres exactly what configuration files to use so it doesn't use any defaults by accident. So here you can see we can set a data directory and tell Postgres what data directory to use. This is handy if we want to mount in volume. Then we can specify an HBA file to use and an ident file to use. Even if your ident file is empty, I would still supply it and maybe just supply an empty file. This means you don't get any sort of surprises if the default one changes. So in my example, I've set this all up. I've set my data directory to /data. So that's very simple. and then I set my HBA file and my ident file to /config. So I'm going to store them and I'm going to mount them into the container under /config. So this allows me to create a configuration volume mount and mount my configs in and supply them to Postgres. This is also important in the future when we take a look at Kubernetes. You might want to compile all your configs as a config map. So on the left, I've created a config folder. I've set my configuration files over here, and I'm going to mount them into the container. The next bit we want to take a look at is the connections and authentication section. Now this is very important as this tells Postgres what address to listen on. It specifies things like the port, so we can override the default port, or we can at least fix it to the right value instead of just relying on the default. There are also important TCP settings you might want to take a look at, like keep alive idle, keep alive interval, keep alive count, and this controls how many connections to keep open with clients and how long to keep them open for. So you don't end up with things like port exhaustion if you're running this database at scale. Then there's authentication settings as well as TLS settings, so we can specify an SSL file. Then there are important settings around memory, like shared buffers, which is by default set to 128 meg. Now, shared buffer parameter determines how much memory is dedicated to the server for caching data. The default should be set to 15% to 25% of the machine's total RAM. So you can go ahead and tune this. For example, if your machine's RAM is 32 gig, then recommended value for shared buffers is 8 gig. So I've set some of these in my configuration file. I've set the port, I've set my listen address, I've set my max connections, shared buffers, dynamic shared memory type. I've just left this as the default. And now you'll see some interesting settings. Max and min wall size. Now we go to the default configuration and you'll notice a section called write ahead log. This is very important, but is more significant in the next video. So you'll see all these settings which are prefixed with WAL, wall. This stands for write ahead log. Now this is exactly what it is. It's writing a log file. It's not a log for debugging or troubleshooting purpose, but it's used more for writing an archive, which is used for primary and standby replication. So you can see there's a wall level set to replica, and this allows us to do replication style logging. So we can tell our primary instance to write to a log and our secondary instance to read from that log and replicate. It's a very important setting, but not super important for learning just the basic configuration of Postgres. We'll be taking a look at this in the next video on replication. The same goes for archiving, as well as the restore command. If we want to take an archive and restore it as a replica, then there's a whole setting on replication as well. There are settings related to the primary server as well as standby servers. We'll take a look at that in our replication guide. So then what I've also configured is our time zone. This is quite important if you want to run your database in a specific time zone. By default, it's set to UTC. You can also specify the date style and the time zone. So the previous time zone is just for the logs, how logs are written, and the other one is just for the time zone that the server operates in. And then you've got some basic locale settings, and these are specific locale settings for like system error messages, monetary formatting, number formatting, and time formatting. And then finally, if you want to dig further into the configuration, there's a lot of tuning options as well. So what we want to do is take these three configuration files that we've created and mount them into our Postgres container. But that's not going to be good enough because Postgres won't know to use those configuration files. So it may end up using the default ones. So it's important to learn that we have to tell Postgres how to use our configuration files. Now there's a few gotchas that I've learned when mounting configuration files into my Postgres container. That if we run on Linux, we need to make sure that the Postgres user, which is going to be running inside of the container, has user ID 999 by default, and it should have access to the configuration files. So if you mount the config files in, you might find that the Postgres user cannot access it. So the way to do it is I just pass ownership to those files so it has access to them. Now there's another gotcha, is that the PG data variable, the environment variable that tells Postgres where our data directory is, has to be updated, because by default it actually looks at varlib PostgreSQL data folder, and we want to change that to /data as per our configuration file here. Now it's important to understand that the configuration file is only read after initialization, so we still have to keep the PG data environment variable to tell Postgres when it starts up, use the /data folder to initialize from. So setting PG data is important here. And the PG data value is the same as our data directory value in the Postgres configuration file. We also set that to /data. So all our data inside of the container is going to be under /data from now on. So you can see we set our environment variables that we learned about, the default Postgres user, password, and database. We still mount our PG data volume that we have on the left-hand side here, just like we did earlier, but we're no longer going to mount it to var lib postgres data /data. We are now going to mount it just to /data because that is what we've told Postgres to use as the data volume. And now in addition to that, we're also going to be mounting in our config file. That is the config folder on the left here, our 3 config files, and we're mounting that into the container on /config. And very important here again, we tell the Postgres configuration file where the 2 configuration files are. So the access and authentication file, and as well as the user mappings file, is specified here and their locations. We still have the same ports exposed, we have not changed that. And here is the most important part. When we start up Postgres, we actually pass a command in to the Postgres container, and we pass in an argument called config_file, and we tell it where the config file is located. And this matches the location of the config file on the left that we're mounting into the container. So when this Postgres instance starts up, the first thing it's going to do is it's going to try to initialize, and it'll use the PG data variable to know that it has to initialize from the data directory. So it'll pick up all our files on the left. Now, rather than picking up these default configuration files, it is going to use this flag that we passed in. So it will initialize from this PostgreSQL configuration file that we've mounted in from the left here, which is this file that I have over here. And when it reads this file, it'll know to use the user mappings and the authentication settings from this location, which is also from the left-hand side here. So that is ultimately how we tell Postgres to use our custom configuration, as well as mounting those configurations in and setting the values. We can go ahead and take this docker run command, paste it to the terminal, and Postgres will now start up and use our config in this config folder. So now we can go ahead and customize Postgres further, and we can use these concepts to then eventually set up a primary and a failover replication server. So that's how we do that using a docker run command. Now for the folks interested, I've also created in my storage database Postgres part 2 folder, I've created a docker compose.yaml file, and everything is in there as well, up to date. So the container name is Postgres, the image we want to run, this is how you pass the command. So we tell Postgres to use the PostgreSql Conf file that we created, our 4 important environment variables, our volumes, so this is going to be our volume for the data folder as well as the config folder, the ports to expose, and we can run adminer as well if we want to play around with the database. And that's very easy to run. I can just quit out of this one and I can say docker compose up, and that'll run the exact same thing I ran before, but this time using docker compose. Now that covers the basics of running Postgres in a Docker container, persisting your data, as well as using custom configuration files and options, and telling Postgres how to use these in a Docker container environment. So now we know how to tune and customize Postgres further. In the next video, we'll take a look at what it takes to set up streaming replication, and we'll want to run one primary instance of Postgres and a standby server in case the primary server goes down, and eventually run all of this in Kubernetes. Now there is still so much more to learn, so if you liked the video, be sure to hit the like button, subscribe, and turn on notifications so you know when part 3 comes out. Now if you want to support the channel, be sure to check the Patreon link down below or hit the join button to become a YouTube member. And as always, thanks for watching, and until next time, peace.